Okay, you guys, now let's go over the notes on the new section, which is solving exponential equations, okay? So, solving exponentials, or I should have said exponential equations. I would just take notes and work along, and then see how you do on your homework. Okay, guys, there are two strategies or methods or whatever you want to call it. And let's start with strategy 1. This is the preferred strategy. This is way easier than what we have to do for strategy 2. However, kind of like factoring and quadratic formula, we'll always factor if we can because it's just so much faster and easier. Sometimes we can't, okay? The other method is a little longer, kind of like quadratic formula. It does always work. So let's dive in, okay? Strategy number 1, make the same base. Let me explain to you what I mean here. Imagine I have this exponential equation. 3 to the x equals 81. Let's do 81, okay? 3 to the x equals 81. This is a very simple one. Maybe you could just tell what the answer is. But bear with me, I want to introduce this method to you, okay? The goal of this is to make the same base. This is a 3 to the x. I want to rewrite 81 to be 3 to the something, if I can, all right? Which I can make 81 3 to the 4th power, all right? It is 3 to the 4th is 81. And now when I rewrite this, I get 3 to the x equals 3 to the 4. Well, the bottoms already match. This will be equivalent as long as this exponent equals that exponent. So now I can just say x equals 4. And there we go, x equals 4, okay? All right. So real quick, you guys, an exponential equation is where x, or your variable, is in the exponent. All right, okay, cool. Let's look at another one. Sometimes I'll have something like 9 to the x equals 27. All right, so let's look at the strategy at play one more time. My goal is to make the same base, all right? Last time, I was able to write 81 as 3 to a power. It matched this. I was good to go. Right now, looking at 9 and 27, I can't make 27 9. But that doesn't mean I can't make them both the same base, all right? I can rewrite 9 as 3 squared. And I can rewrite 27 as 3 cubed. So I could change them both to turn them into the same base. All right, so take a look. 9 would be 3 squared, and it already had an exponent, x, that just gets multiplied by the exponent that I brought in, okay? And then on this side, 27 is 3 to the 3rd. Okay, now the bottoms match, which means that this exponent must equal that exponent. It means that 2x has to equal 3 for this to be true. And now, easy peasy, divide both sides by 2. X equals 3 over 2. Okay? All right. Hope you guys are following along and it's going okay. Let's keep it going. Sometimes the exponents are ugly. Who cares? If I say 5 to the 3 minus 2x power equals 5 to the negative x power, look at that. I want to make the bases the same, and they already are, okay? Boom, boom. I get 3 minus 2x has to equal negative x. Solve this equation however you like. There are lots of different orders in which you can do things. X equals 3, okay? Let's see if there's another really good example to do. good. I think that's good. Let me see your homework. Let's take a look. Does this mean you should be able to do all of this now? You can't do 1 through 6 because those are different. Or 1 through 10 technically. No, none of these. These all want logs. Ooh, those all want logs. Okay. Okay. You know what? I'm gonna have to add a couple of problems that use this technique to your homework because none of your homework has it. Okay, so hopefully you guys got this. Now let's go look at strategy number 2 because this easy peasy, everything works out nice thing doesn't always happen, all right? So strategy 2, when we cannot make the same base, we will use logs, okay? Alrighty. Now this strategy does branch out into 2 different ways of doing it. It's the same thing. Some people prefer one way, some people prefer another way. So let me just kind of give you an example to introduce this. Let's look at what if 2 to the x minus 5 equaled 24, okay? Now there's no way because 24 has a 3 in it, right? There's no way I'm gonna make it the same base. That's just not gonna happen, you guys. So let me show you what we can do. Method 1 is to log both sides, all right? We're always gonna log both sides. However, if my plan is to use the calculator, and most calculators can either only do ln or log base 10, okay? So even though a log base 2 is what eliminates this, okay, I'm actually just gonna ln both sides, okay? You could choose any log you want. I'm choosing ln because a calculator can do ln. So, ln both sides, what happens? We get ln of 2 to the x minus 5 equals ln of 24. All right, now let's use properties of logs to finish this. This x minus 5 is an exponent. Luckily, now that it's in a log, because I logged both sides, I can drop it to the front. So this becomes x minus 5 ln of 2 equals ln of 24. Okay? And now I can divide both sides by this ln of 2 so that I can start getting to x over here. Now, quick understanding check, you guys. ln of 2 is just a number. ln of 24 is just a number. So this is just like if it was 5, this is like me dividing both sides by 5 right now. And this thing, as ugly as it looks, it is just a number. So currently I have x minus 5 equals a number. All right? If you really are uncomfortable with this, go to your calculator, punch it in, and see what number it is. Okay? If you do though, please keep like 4 decimal places. And then now, x minus 5 equals a number. I can solve for x so easily. Just add 5 to both sides. X equals ln of 24 divided by ln of 2 plus 5. Okay? Which now, in the calculator, where's my calculator? There it is. Let's see what it is. Ln of 24 divided by ln of 2, close those parentheses, guys, plus 5. It's 9.58 50. You guys, some rounding can go a long way when we're dealing with exponentials. So please, I always want 4 decimal places for accuracy. Okay. So this was strategy 2, using logs. But remember I told you there's 2 ways to do this, okay? Let me show you the other way. Let's do the same problem. Let's take a look back at 2 to the x minus 5 equals 24. And let me show you this second way, which is gonna lead us to the change of base formula. Take a look, all right? I'm still gonna start it like before by logging both sides. However, this time, I don't care to use ln or log base 10 just because the calculator can do them. This time, what I wanna do is use log base 2. I wanna use log base 2. Why? Because it cancels this out and everything turns out beautiful afterwards, all right? So we're gonna log base 2 both sides. Here we go. Log base 2 of 2 to the x minus 5 equals log base 2 of 24. Okay, now look. Log base 2, exponential base of 2, cancel, and I get x minus 5 equals log base 2 of 20. Ooh, what was that? How did 24 become 2 to the 4th? Log base 2 of 24, okay? And now, log base 2 of 24 is just a number. So I have x minus 5 equals just a number. I'm gonna just add 5 to both sides. And I get x equals log base 2 of 24 plus 5. I'm gonna be super careful to write it with lots of good distance, even put the 24 in parentheses to ensure that I don't think that I can add 24 and 5 because I absolutely cannot. Okay, here we are. You guys, check it out. Log base 2 of 24 plus 5 is just a number. It's the answer. However, because most calculators cannot do a log base 2 of 24, I don't know how to turn this into a decimal. Okay, like I did before when I did the ln way. But check it out. If x is equal to this, and now using a different method, I found that same x to be equal to this. Here's what that means. Let's use a different, no, let's just keep going. That means that log base 2 of 24 plus 5 is the same thing as this, as ln of 24 divided by ln of 2 plus 5. Ooh, you can't see that plus 5. Can I make you see it? There it is, plus 5, okay? Now, the first thing I'm gonna do, this plus 5, that plus 5, I want them out of here. I'm gonna go minus 5 on both sides, just to get rid of it so I could focus on the important stuff. What I have is log base 2 of 24 equals ln of 24 over ln of 2. And this right here is huge, you guys, because I could have done this with any number here and any number here. And at the end of it, I would have still ended up with log base something of something is the same as me changing it to a different log of this big number divided by log of the base. So this is actually the change of base formula. It says we can take log base anything of anything, and we can rewrite it as log base whatever we want, anything else, of this guy divided by log base whatever we want of this guy. Okay? Now, we're not going to pick some random number for A. We're always either going to pick E to get ln, because the calculator can do ln, or we'll use a log base 10, a common log. All right? But the key is you could take whatever log you have, and as long as you do log of this divided by log of this, that you could change the base to whatever you want. So at this point in time right here, if I did this method, what I would do now is come here and do change of base formula to get a decimal. I would say this is the same as log 24 divided by log 2 plus 5. That's the change of base formula I just applied to this. And you could punch this into the calculator and see that it's the same exact thing as this. Same thing, okay? Okay. Hope that made sense. If not, feel free to rewatch it. I'm gonna do one more example, and then hopefully it does. Let's take a look at another example. Let's do, I like this one. Let's do 7 times 2 to the 3x power equals 840. So you guys, step number 1. Before I even get started, I want this thing isolated. So the first thing, this 7 is fluff. First step, get rid of the fluff. I'm gonna divide both sides by 7. Get that out of there. 2 to the 3x equals 120. Okay, here I am, all right? I can tell 120 has a 5 in it. No way I'm gonna make it the same base as that 2, okay? So I'm just gonna go into logs, all right? Now, you can either ln both sides or log both sides. That's option 1. And option 2 is to log base 2 both sides, okay? Now, personally, you guys, I do think this is simpler. And then do change of base at the end. So take a look. I'm gonna log base 2 of 2 to the 3x equals log base 2 of 120. And now this cancels this, and I end up with a not so bad thing. 3x equals log base 2 of 120, okay? Now guess what? Log base 2 of 120 is just a number. And if I just divide it by 3, that's x. Okay? And the final answer is x equals log base 2 of 120 divided by 3, or I could make it 1/3 in the front. It's the same thing. Okay? Final answer. This is an acceptable answer. However, if I now wanted a decimal approximation, I don't know what log base 2 of 120 is, to be honest with you. But I do know that my calculator can do that if I turn it into an ln or a log. So I'll make it log of 120 divided by log of 2. This I can punch into the calculator and get the answer, okay? Also, you could have chosen instead of log to go with ln. Same, it'll come out exactly the same, all right? Final answer. Let's see what it is. Let's go 1/3 times ln of 120 divided by ln of 2 2.3023. Oh, wait a minute. I made a little mistake in my symbols here. These aren't approximately equals to. This is actually completely 100% equal to this. And then now this as a decimal is 2.3023. And right here, just to show you, it's the same. Oh, that was the ln one. Oh no, you guys, I hope I didn't confuse you. I typed in ln instead of log. So that technically should have gone here. However, they're exactly the same. So look, if I do 1/3 log of 120, close a parenthesis, divided by log of 2. Look at that, same exact number, all right? It didn't matter that I mixed it up. Okay, all right. Last thing, you guys, that I'm gonna leave you with, all right? Let me show you the most common mistake with change of base formula. ln of 120 divided by ln of 2 is absolutely not equal to ln of 60. Do not divide those two. You can't do it. It's not true, okay? So please be very, very careful. This is ln of 120 divided by ln of 2. There's no further simplification that we can do here, okay? All right, so that's it. You could do your homework. I hope you guys got it. I'll see you next time.